Hello everyone, let's begin our class with number system, and today we are going to start with divisibility. Now a number x is said to be divisible by another number y if it's completely divisible by y, that is, it should leave no remainder, right? Now in general it can be said that any integer I when divided by a natural number n exists a unique pair of numbers q and r which are called your quotient and your remainder respectively. I can also say that I equals to qn plus r where q is nothing but an integer and n is a natural number or 0. Alright, that means remainder has to be a whole number less than n. So this is nothing but your remainder and this is nothing but your quotient where n is what? Your natural number, right? Now if the remainder is 0, we can say that number I is divided by n, correct? Or I can say that number I is completely divided by n. And when is that going to happen? When r is going to be equal to what? 0. But suppose my r is not equal to 0. Let me change the color. So if r is not equal to 0, in that case what's going to happen? I would say that number I is divisible by n with a remainder, and that remainder can be anything given that I n can be anything. So that remainder can also be anything. Thus, for example, if I explain you with an example. Now suppose 25 is divided by 8. Now if I have to divide 25 by 8, can I write this in the format 25 equals to 3 times 8 plus 1. Now why did I write it in this format? Obviously 3 times 8 is nothing but your 24, and when 24 plus 1, then what it gets me is 25. That means 3 times 8 is 24 and adding 1 to 24 is going to get me what? 25. So naturally I can expand 25 in this format, correct? Now here 3 is going to be the quotient whereas 1 is going to be the remainder, and this is exactly what I was explaining to you in this. Alright, so I hope you people understood what divisibility is. Now let's move forward and read about the theorems of divisibility. They are pretty simple. So what does the theorems of divisibility say? There are 5 theorems as you can see. So the number 1 point is, if A is divisible by B, then A and C is also divisible by B. That is naturally true. Like for example, if there is a number 12, I can say that 12 is divisible by 2, which is correct. And if I take like 12 multiplied by 3, then obviously this number is also divisible by 2. So therefore A holds true. And B, it says if A is divisible by B and B is actually divisible by C, then A is divisible by C. What does it mean? Suppose A is divisible by B. Okay, so let A be 12 and B be 6. So this is my A and this is my B. Okay, and I would say that what should be C here? Let's read it again. Okay, if A is divisible by B and B is divisible by C, so this is my B. Suppose I take C as 3. So this is my C. Okay, this is 3. So then they are saying then A is also divisible by C, and that is true here because what? 12 is actually divisible by 3. So this holds true here. Correct. So B is also true. Number C. If A and B are natural numbers such that A is divisible by B and B is divisible by A, then A is actually equals to B. That I think is correct. How? Let's suppose A is divisible by B completely, okay, and B is divisible by A completely. So that means when I actually divide A by B, I get 0, and when I divide B by A, again I'm getting what? 0 as a remainder. That means what? Now in the previous slide, what I told you that I should be equal to Qn plus R. Now here A is divisible by B, so I can write this in the format of that A equals to quotient times B. Okay, and here this I can write it in the format of what? I can say this as B equals to quotient by A. Now if I see this equation and if I see this equation, can I compare the two and say, all right, A is nothing but it's equal to B because quotient is what? 1. I can very well say that because I have two equations. The first equation here is A equals to QB and second equation is Q times A equals to B. Now this can only hold true when Q is nothing but 1. So that means C also holds true. Then comes your N. Now if N is divisible by D and M is divisible by D, then M plus N and M minus N are both divisible by D. Now let's take another example now. Okay, so if N is divisible by D, let's say N is maybe 12. So 12 is divisible by D. So let me take D as 3. Okay, and M is also divisible by D. So I will consider M as 9 and obviously I have D as 3. So 9 by 3. Let me repeat it. N is divisible by D. Here I take N as 12 and D as 3. And M is divisible by D. So M is 9 and D is 3, as you people know. Now they are saying that M plus N and M minus N are also divisible by D. So what's going to be M plus N? 12 plus 9, it's going to be 21. We all know that 21 is divisible by 3. And M minus N, 12 minus 9 is nothing but 3. And we know that 3 is divisible by 3. Number is divisible by number itself. So that means D also holds true. Number 5. If A is divisible by B and C is divisible by D, then AC is divisible by BD. Now what they are trying to say is that if there is a number that is divisible by B and another number that is divisible by another number, then actually the product of A and C is going to be divisible by the product of B and D. Now let's suppose A is 4 and B is 2 and C is your 12 and D is your 3, or maybe C is your 9. Okay, so 4 into 9 is going to be divisible by 2 into 6. This is absolutely correct. You can take it, you can do it. 2 and here 3, so answer is going to be 6. Okay, so the quotient is going to be 6 and your remainder is going to be 0 here. Alright, so I hope you people understood what are the theorems of divisibility actually. So now let's move on. Okay, so here is what? It's your standard form. Now we all have done what the standard form is, right? Now we have already seen earlier that any composite number can be written down as a product of its prime factors, which is also known as your standard form. Like for example, I can say that 1240, let's suppose I take this an example. This can be written in the format 2 raised to power 3 multiplied by 31 raised to power 1 multiplied by 5 raised to power 1. So this is what my answer is going to be if I write 1240 in what? In my standard format. Okay. Now the standard form of any number has a huge amount of information stored in it. We have seen it. It has a huge amount of information stored in it. Now the best way to understand the information stored in the standard form of a number is actually to look at the concrete examples. And as a reader, I want you to understand each of these processes which I am going to define right now and use them to actually solve the questions. Okay. So the first point here is using the standard form of a number to find the sum and the number of factors of the number. And the first point is sum of factors of a number. Okay. Let's understand this with the help of an example. Now, suppose we have to find the sum of factors of the number, say 240. So can I write 240 as 2 to the power 4 into 3 to the power 1 into 5 to the power 1, which is true. Now I need to find out the sum of the factors. Okay. So what are going to be the sum of the factors? Okay. So now can I write this sum of the factors actually as 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4 times 3 to the power 0 plus 3 to the power 1 times 5 to the power 0 plus 5 to the power 1, which is going to be nothing but 31 times 4 times 6, okay, which is nothing but 744. So this is going to be what? The sum of the factors. Now how did I actually do this? Okay, Now understand this, okay? I'm not going to explain this. I am not going to like elaborate it in that format, but I'm just going to tell you a little bit because you people already know this, so I do not want to waste my time on this. Now see, the factors of this can be given by this. That means if I can multiply 2 into 3 into 5, or if I can only take 3, or if I can only take 5, or if I can only take 2, or only 2 into 2, 2 into 2 into 2, or 2 into 2 into 3 into 5, like all these are going to be the factors of these. So what I actually did is I added. अब इसका एक simple process क्या होता है? Like for example, there are these brackets, right? अगर मैं brackets open करूँगी, then I'm going to like multiply 2 to the power 0 with 3 to the power 0 and 5 to the power 0, and then 2 to the power 0 with 3 to the power 1, and then this multiply by 3 to the power 1 into 5 to the power 1. This is how I'm going to open the bracket, okay? And you all know how to open these brackets to get all the numbers which can possibly be ever made out of this, okay? So this is how you can actually get all the factors, and that is exactly what I have done. It's very, very simple. Just go and give it a read. If you people do not understand this, just put in a comment and I'm going to answer it again. Because I feel that you people know this, so there is no need to actually kill time on it. Okay. Next is number of factors of a number. Okay, I do not have space here, so okay, let me do one thing. Wait. We were talking about standard form, right? So yeah, let's talk about the number of factors of a number. So what I'm going to do here is, now let's explore the sum of factors of 14 different contexts. Okay, so let's take 40. Now if I'm taking 40 here, I'm so sorry. Okay, we were on number 2, okay, and I'm taking 40 here. Okay, so what I'm thinking of doing is, let me explain all these points to you, and then I do not why I feel that the sum of the factors part थोड़ा सा जो है वो मैं दोबारा से आप लोगों को explain कर दूँगी if you people want that. Okay, so the number of factors of the number, and I'm taking 40 for that. Now obviously I can write 40 how? 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 into 5 times 0 plus 5 times 1, correct? Now this, when I am going to expand it, okay, if I'm going to expand it, how I'm going to write this? I'm going to write this 2 to the power 0 into 5 to the power 0. Yes, please concentrate everyone on this, because ये जो चीज़ मैं explain कर रही हूँ, it will cover the sum of the factors of a sum वाला part as well. Okay, so I do not have to go back to that again and explain that all over again. So just understand what I'm trying to do here, okay? So if I'm going to open the bracket, it will be 2 to the power 0 times 5 to the power 0, then 2 to the power 0 times 5 to the power 1, then 2 to the power 1 times 5 to the power 0, then 2 to the power 1 times 5 to the power 1, then 2 to the power 2 times 5 to the power 0, then 2 to the power 2 times 5 to the power 1, then 2 to the power 3 times 5 to the power 0, and 2 to the power 3 times 5 to the power 1. So these are actually all the factors which can possibly be made of number 40. Now the thing is, how did I do this? Okay, मैंने ये कैसे किया? अब देखो यार, इसका simple method क्या है? Like there is 40, okay. Now there is 40. अब अगर मैं 40 के सारे factors निकालूंगी, it will be 2 times 20, 2, then 10, 2, 5, 5 and 1. Okay, that means 2, the maximum power of 2 which I can get is 3. Because 40 is nothing but 2 to the power 3 times 5. Okay, now if I want to find the factors of 2, can I say that factor of 2 is 5? Of course I can say. But how can I write 5 while incorporating 2 with it? I can say that 5 can be written as 2 to the power 0 times 5 to the power 1. Correct? Similarly, if I say that 2 to the 2 is also one of the factors, now how can I write 2 given the fact that the exponent of 5 is 0? So I can write 2 to the power 1 and 5 times 0. Like this, what I can do is I can make all the possible factors which can be made out of the number 40. Now to simplify this, what we did very, very simply, 40 के हमने factors देख लिए किस तरह से होंगे. So 2 to the power 3 into 5 are the factors of 40. So what I actually did is कि 2 की सबसे lowest power क्या हो सकती है? 0, correct. And highest power क्या हो सकती है? 3. So what I did was कि in this just see what I'm underlining. In this मैंने सारी उन factors को add कर दिया of 2. Okay, so 2 to the power 0 which can be the lowest possible thing, and 2 to the power 3 which can be the highest possible thing which is given. So I added all of this, and similarly I did for 5. तो मैंने 5 की lowest ले ली और 5 की highest ले ली, and I put them in separate brackets. अब suppose यहाँ पर 3 का भी होता तो मैं 3 को भी एक अलग ब्रैकेट में डाल देती. बस मुझे क्या करना है, जितने भी अलग अलग फैक्टर्स हैं उनकी लोएस्ट और हाईएस्ट के बीच में जितने भी फैक्टर्स बनते हैं व्हेन आई एक्चुअली रेज द पावर, उन सबको ऐड करके आई एम जस्ट गोइंग टू पुट देम इन ब्रैकेट्स. Alright, this is one of the simplest method to actually find all the factors, and obviously other things as well, like number of factors of the number, then sum of factors of a number, and rest we are going to see further as well. Because why did we do this? You know, there is reason. There is a reason. We do not do anything like out of reason. This is nothing like that. Okay. So why I'm doing this is because when I'm going to open these two brackets, the bracket with this one and the second bracket this one, when I'm going to open these brackets and when I'm actually going to multiply these numbers, like 2 with this, then with this, then 2 to the power 1 with 5 this and this, then 2 to the power 2 with 5 and this, then this with this and this. When I'm going to multiply, then this is going to happen, and this expansion is actually going to give me all the possible factors of number 40. So I do not have to worry about कि कोई factor रह तो नहीं गया, or maybe if there is any other possible factor which can actually occur and I do not know of. Alright, so I do not have to worry about that stuff happening if I am doing it in this way. So this is the number of factors of a number, and I've explained you how to actually calculate the number of factors possible. Okay, so we have actually done the expansion here. Now I have done the expansion here. Now what I'm going to do is I'm going to see what is it. Now 2 to the power 0 and 5 to the power 0, the first one you cannot see, I have written here. This is going to be 1 plus 2 to the power 0 into 5 to the power 1 is going to be 5. Then it's going to be 2, then it's going to be 10, then it's going to be 4, then it's going to be 20, then it's going to be what? 8, and then it's finally going to be 40. And this all, adding all of this is going to give me what? It's going to give me 90. Alright, now a clear look at the number above, that is your 40, will make you realize that it's nothing but the addition of factors of 40, which is true. Hence we realize that the number of terms in the expansion which I have given you, and this is the expansion that I am talking about, will give us the number of factors of 40. Hence 40 has how many factors? 4 times 2. That is 8 factors. Why 8 factors? Because there are 4 possible exponents of 2 and 2 possible exponents of 5. So 4 times 2 is nothing but 8. Correct? Correct. Now let's move forward. Now, okay, I'm again going to put on with some space. Okay, correct. Okay. So we are on point number 2, and point number 2 says sum and number of even and odd factors of a number. So I can also calculate the sum and number of even and odd factors of a number in this. Now how we are going to do this? Let's see. Okay. Now suppose I am trying to find out the number of factors of a number represented in its standard form. Alright, let's form a standard form. So suppose the standard form which I am considering is 2 to the power 3 times 3 to the power 4 times 5 to the power 2 times, let's say, 7 to the power 3. Okay, now this is the standard form which I am considering. Alright, now as we already are aware of that the answer to the question is going to be what? 3 plus 1, because 3 is the exponent of 2. Alright, so the maximum exponents possible is going to be 4. Why? Because 0 is also added in this. Similarly, 4 plus 1, 2 plus 1 and 3 plus 1 is what? And this whole is based on the logic that the number of terms will be same as the number of terms in the expansion. And what is the expansion we are holding in this? We are holding 2 to the power 0, 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 times 3 to the power 0 plus 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3 plus 3 to the power 4 times 5 to the power 0 plus 5 to the power 1 plus 5 to the power 2 times 7 to the power 0 plus, I'm so sorry, where did it go? Where did it go? Yeah, 7 to the power 0 plus 7 to the power 1 plus 7 to the power 2 plus 7 to the power 3. So this is nothing, but this is the expansion which is possible. Now suppose you have to find out the sum of the even factors of this number. So what are going to be the sum of the even factors? Okay, now if I want to find out the sum of the even factors, obviously 3 out of 2, 3, 5 and 7, if I'm not going to have 2, then that number is going to be what? That number is going to be nothing but odd. And if I'm going to have 2, then that number is going to be what? Even. That means if I want to find all the even factors, then I cannot include 2 to the power 0. Because if I'm including 2 to the power 0, then there will be some factors which are included in this, which are going to be odd when I'm going to open this expansion. That means I'm not going to include 2 to the power 2. That means the highest exponent of 2 is going to be 3. So it's going to be what? 3 plus highest exponent of 3 is going to be the number of exponents, actually 4. Then the number of exponents of 5 is going to be 3. The number of exponents of 7 are going to be what? 4. Correct. So this is what my answer is going to be. Now since 2 to the power 0 is eliminated, we do not add 1 to the bracket corresponding to 2. So let's now try to expand our thinking to try to think about the number of odd factors of a number. Now obviously in that case, we just have to do the opposite of just exactly what we did right now. Because मुझे odd number चाहिए, so what I'm going to do is I have to eliminate all the factors that are going to have 2. That means the highest possible exponent numbers of 2 is going to be only 1. And that is going to be what? 2 to the power 0. Because 2 to the power 0 is nothing but 1. Alright, so 2 to the power 0 is nothing but 1. That means the highest exponent of 2 is going to be what? 1. That means 1. Then 3 can be what? 4 plus 1. 3 can be 5. Then 5 can be your 3. And 7 can be your 4. So multiplying this will give you the number of odd factors of the numbers. So I hope you understand कि odd and even factors of the numbers को कैसे calculate करना है. It's pretty simple. If you want to find the even one, then you just have to keep all the exponential things of 2 which are there, which you can possibly create. And if you want to keep the odd one, then you have to eliminate all the possible exponential forms of 2 which can be possibly made. Alright. So now the last point. The last point says sum and number of factors satisfying other conditions for any composite numbers. So this is the last point which I have to study. Again, what I'm going to do is I'm going to just make it a clear page. Yeah. So now let's start with this. Now let me explain this best with the help of an example. Okay. Now let's find the sum and the number of factors of a number which is what? 1, 2, 0, 0, such that the factors are divisible by what? 15. So what I need to do is I need to find the sum of the factors that are divisible by 15 and the number of factors that are divisible by 15, and those factors have to be of the number what? 1 to 00. Correct, right? Now find the sum and the number of the factors of this. I have to do that. Correct. So what is going to be the solution here? Can I write 1200 in the format of 2 to the power 4 times 5 to the power 2 times 3 to the power 1? This is the format. This is the standard format in which I can write 1200. Now for a factor to be divisible by 15, it should have what? If a factor has to be divisible by 15, it should be divisible by 5 times 3. So that means it should have minimum 5 times 3 in that. That means it cannot, now this cannot contain 5 to the power 0 and this cannot contain 3 to the power 0. Okay, now all the factors that are divisible by 15 are going to be what? 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4 from here. Now 5 has to be there, so I cannot write 5 to the power 0, it has to be 5 to the power 1 plus 5 to the power 2. Now 3 to the power 1 is there, but I cannot write 3 to the power 0, so it has to be 3 to the power 1. So if I am going to see this, then this is going to give me all the factors which are going to be divisible by 15, the sum of them. And this is going to be what exactly? This is going to be, let me calculate it. Okay, so this is going to be the sum. I think you people can calculate it. Now let's find the number of factors which will be given. So what will be the number of factors? The highest exponent is 2 to the power 4. So 4 plus 1, highest exponent is 2. So it's going to be what? It's going to be 2 only because there is no 0. Highest exponent is 1, but it's going to be 1 only because there is no 0. So 5 times 2 times 1. So this is nothing but 10. That means the number of factors will be given by 5 times 2 times 1, which is nothing but 10. So let's move forward now. Okay. So I hope you people understood this. So next is what? Next is the number of zeros in an expansion. Now this is very, very simple. Okay. I have to find the number of zeros in this and the number of zeros in this. And by the help of these questions itself, I'm going to understand what this concept actually is. Now suppose you have to find the number of zeros in the first one. Okay. Now as I can notice, this product will have no zeros because there is no 5. Why? Because there is 2 in that. And 0 is only going to be made when there is any kind of 10 in that. And 10 is going to be made while multiplying 2 times 5. Now I can clearly see that there is 2. But I can also see that there is no 5. That means there is going to be no 0 because it has no 5. Okay. So the number of zeros in the first one is going to be 0 only. Okay. The second question. Second question states that I have to find the number of zeros in this expression. Now, can I write this expression in its standard form? Of course, I can write it. I can write this in the format of 2 to the power 3 times 3 to the power 1 times 2 to the power 3 times 1 times 5 to the power 2 times 2 to the power 1 times 11 to the power 1. So this is how I'm going to expand this expression. Alright. Now the number of zeros are going to be formed by the combination of 2 times 5. Hence the number of zeros will depend upon the number of pairs of 2 and 5 that can be formed. Now in this product, I can say that there are 4 2s and 3 5s. Alright, if there are 4 2s and 3 5s, that means the number of pairs of 2 times 5 can be 3 only. Hence, there are going to be 3 zeros in this because 2 times 5 is what? 10 and 3 times this pair happens. So, this is what going to be? Number of 3s are going to be, number of zeros are going to be 3, not number of 3s. I'm so sorry for that. So, number of zeros are going to be 3 in this. Now, we have found the number of zeros in an expression. Let's find out the number of zeros in factorial format as well. Okay, so let's find it out. In factorial format, what is going to happen? The factorial which I am using is 6 factorial. Now, I know that I can write this factorial 6 factorial in, it can be written as 6 into 5 into 4 into 3 into 2 into 1. So, I am multiplying all of these. Okay, I am multiplying all of these. So, 6 can be written as 2 times 3, then 5 can be written as it is, then 4 can be written as 2 times 2, then 3 can be written as it is, 2 can be written as it is, and 1 can be written as it is. Now, same way, in same format, I can say that the number of zeros will depend upon the number of pairs of 2 times 5. So, how many 2s are there? 1, 2, 3 and 4. How many 5 are there? 5 is only 1. That means number of pairs of 5 and 2 are only 1. That means number of zeros which are going to be there is only 1. So, there is going to be only one number of 0. Correct? Correct. So let's move to next topic, and our next topic is co-prime or relatively prime numbers. So what I'm going to do here is I'm going to explain what these are and then we are going to solve a question. Okay. So what actually are your co-prime or relatively prime numbers? Now 2 or more numbers that do not have a common factor are known as co-prime or relatively prime numbers. Okay. In other words, I can say that these numbers have the highest common factor of unity. Now, if 2 numbers are there and those numbers are m and n and relatively prime, they are relatively prime, and the natural number x is basically divisible by both m and n independently, then the number x is also divisible by what? mn. So, this is basically what your co-prime or relatively prime numbers are. Let's do an example and understand it more clearly. Now, the question says, find all the 5-digit numbers of the form this that are divisible by 36. Now, before beginning with this answer, or you can say question, let's give a thought on the prime numbers first, okay, so that I'm sure that you people know it. Okay, we are going in wrong direction, I feel. Okay, so co-prime or relatively prime numbers. I'm going to read this again so that I have a satisfaction that you people have understood it. All right. Two or more numbers that do not have a common factor are known as co-prime or relatively prime numbers. In other words, these numbers have the highest common factor of unity. If two numbers m and n are relatively prime numbers, or you can say co-prime numbers, and are natural numbers, and the natural number, the natural number x is divisible by both m and n, independently, then number x is also divisible by mn. That is true because x is divisible by n and x is also divisible by n. That means x is going to be divisible by the product mn. What they are saying is that m and n has to be relatively prime numbers. Okay, they have to be relative prime numbers. Okay, relative prime numbers are which do not have a common factor. Let me take m as 2 and n as 3 and natural number x as 6. Now 6 is divisible by 2, correct. 6 is divisible by 3, correct. 6 is divisible by the product of 2 and 3, that is nothing but 6, that is 6 is divisible by 6, correct. So this holds true. So let's go to the question. The question says, I'm going to read this again. Find all the 5-digit numbers of the form 35 times x into 5y that are divisible by your 36. So what I'm going to do here is 36 is a product of what? 36 is product of 4 and 9. Okay. Now hence if 34 times x times y, it's not times, it's actually 34x by y. It's a number, it's not times. I spelled it wrong. So hence if this number is divisible by 4 and 9, it will also be divisible by 36. Correct? Because if this number is actually divisible by 4 and 9, it will also be divisible by 36, correct? Hence what we need to do is we need to apply the divisibility of 4 and we have to apply the divisibility of 9. So if I take the divisibility of 4, can I say that if any number is divisible by 4, we can have the value of y as 2 or 6? Because what? Like if I see the divisibility of 4, I can say that the value of y can be 2 or 6 because of the divisibility rule which we have done. Okay, I'm also going to explain the divisibility rule and discuss with you in further slides. But you people know the divisibility of 4, right? And because of the divisibility of 4, we can say that the value of y can either be 2 or 6. And also if I say that y is 2, then this number is going to be what? This number is going to be 3, 4, x, 5, 2. Correct. Now, if I want to make this divisible by 9, then the addition of all of this has to be divisible by 9. That means 3 plus 4 plus x plus 5 plus 2 has to be divisible by 9. Okay. And if x is 4, not x is 4, but okay, 3 plus 4 plus x plus 5 plus 2 should be divisible by 9, correct. For this x can be 4. If I take x as 4, yes, it can happen. Hence the number this is divisible by 36. So I can say that this number is divisible by 6. How? When my x is 4, that means this becomes 3, 4, 4, 5, 2. Correct. And also if my y is 6, that means this number is 3, 4, x, 5, 6. Now for this number to be divisible by 9, the summation of these has to be what? Divisible by 9. So for y equals to 6, the number this number is going to be divisible by 36 when the addition of the digits is actually divisible by 9. Okay, this will happen when 5 plus 6 is 11, 15, 16, 17, 18. So I can say that either x can be 0 or it can be 9. Correct, then only it's going to be divisible. So what are going to be the numbers? They are going to be 3, 4, 0, 5, 6 or 3, 4, 9, 5, 6. These numbers came out of when y is 6 and when y was 2. This is the number that came out. So hence this is the number, this is a number and this is a number. Alright, correct. So let's move on to your divisibility rules which I was talking of. So the previous question which we solved, it was related to what? The divisibility rule. We actually saw how to use the divisibility of 4 and obviously of 9 as well. Correct? So let's just go through these divisibility rules because they are pretty simple. Okay. Like for example, what is the divisibility of 2 and 5? A number which is divisible by 2 or 5 if the last digit is actually divisible by 2 or 5. Then what is the divisibility of 3 or 9? All such numbers, the sum of whose digits are divisible by 3 or 9 are divisible by 3 or 9. Then the divisibility of 4. Divisibility of 4 says a number is divisible by 4 if the last two digits are divisible by 4. Then divisibility by 6. A number is divisible by 6 if it's simultaneously divisible by 2 and 3. Next paper, it is divisibility of 8. So in divisibility of 8, I can say a number is divisible by 8 if the last three digits of the number are divisible by 8. Then what is the divisibility of 11? Divisibility of 11 is a number is divisible by 11 if the difference of sum of digits in odd places, it's odd places, and the sum of digits in the even places is 0 or is actually divisible by what? 11. Then divisibility of 12. All the numbers which are divisible by 3 and 4 are divisible by 12. Then divisibility of 7, 11 and 13. The integer n is divisible by 7, 11 or 13 if and only if the difference of number of its thousands and the remainder of its division by 1000 is divisible by 7, 11 and 13. So let me take an example to explain you the divisibility of 7 because that I felt is the most complicated one. Okay. So let me take an example and the example says, the example says 4, 7, 3, 3, 1 and let me take 2. Okay. So this is the number and I have to check whether it's divisible by 7 or not. So since the difference between 473 and 312, because what I need to do for the divisibility of 7, 11 or 13 is that I actually have to subtract this with that. Now this, the difference is going to be what? It's going to be 161. I'm so sorry for this. I don't know what's happening with my pen, but the difference is going to be 161, right? And is 161 divisible by 7? Of course it is. 23 per. Okay. So at 23, this is divisible by 7. So that means that this number is divisible by 7. So this is how you need to check the divisibility. I've explained you with an example. You can do all the other questions on basis of this only. Okay. Now next is what? Next is our remainder theorem. Now what does the remainder theorem tells us? Now the remainder theorem. So I have to find the remainder of this number when it's divided by 12. Now I have to consider this equation. Okay, that's 17 times 23 has to be divided by 12. Now can I write 17 into 23 as 12 plus 5 times 12 plus 11? Correct. Now when I expand this, can it give me 12 times 12 plus 12 times 11 plus 5 times 12 plus 5 times 11 is actually, I'm so sorry, is actually divisible by what? 12. Correct? This is correct. Now you will realize that when this expression is divided by 12, the remainder will only depend upon the last term of the number. Okay, it will only depend upon the last term, which basically means what? Which means 12 times 12 times 12 times 11 is going to be, with the addition of 5 times 12, with the addition of 5 times your 11, this is going to give the same remainder as 5 times 11 by 12, which is nothing but what? So the answer is going to be what? 7. Now this is the remainder when 17 times 23 is actually divided by 12. So the remainder is going to be what? The remainder here is going to be 7. The thing is that I actually wrote this in this format first, then I expanded it. Then with the help of common sense and a bit of maths, I can basically say that when I expand this, it could be this. And I would also say that the last digit which was basically there, that is going to give me the same remainder, 5 times 11 by 12. Hence, 7 is going to be what? The remainder when 17 times 23 is divided by 12. So it's just the remainder theorem, a little question from the remainder theorem itself. This is how you people need to do it. I personally feel that the divisibility one which I told you in the beginning and this remainder one is quite similar to one another. So you do not have to worry if you have already done the divisibility one. Okay, you just do not have to worry about that. Okay, next. Base system in this. So what is your base system? Now all the work which we have carried out with the numbers is basically what your decimal system. Okay, in other words, I can basically say that that is your decimal system. Correct. Now why is it called your decimal system? Why? It's because there are 10 digits in the system from your 0 to now 9. Okay. Now however, depending upon the number of digits that are contained in the base system, other number of systems are also possible. For example, if I take base as 2, then my system is going to be referred to as binary. If my base is 8, then it's going to be octal. If it's 16, then it's going to be hexadecimal. Now binary has going to be 2 digits, that is 0 and 1. Octal has to have 8 digits, that is what? It's going to have 0, 1, 2, 3 till 7. Hexadecimal will have 16 from 0 to 9. Then it will start from A, B, C, D, E, where A is going to be nothing but 10, 11, 12 and so on. So this is basically what? It's the base system. You can see in the next slide that these are the decimal numbers which are given, then corresponding binary values of these, then corresponding octal values of these and corresponding hexadecimal values of these. So 11 numbers are given. So binary can only be 0 and 1. So all binary terms are written in 0 and 1 itself. And then in octal it has to be 8. So after 8, like obviously 8 is not going to be there because we are actually considering 0. So it has to be till 7. Then it's going to be 10, 11, 12, 13. Okay. And in hexadecimal it's 16. So it's going to continue till 9 and then A, B, C, D, whatever it is, till F it is. Okay. So next is, okay, here's a question and they are saying that we have to write the decimal equivalent of base 8 number, which is nothing but 1468. It's pretty simple. Can I write 1468 as 1 times 8 square plus 4 times 8 to the power 1 plus 6 times 8 to the power 0? I can write it in this format. So if I'm going to elaborate it, this is going to be nothing but 64. This is going to be nothing but 32 and this is going to be nothing but 6. So if I'm going to add all these, then it's going to be what? It's going to be 102. Correct? So this is basically your base number. So yeah. So we actually reached the end of our session. So let me give you a quick review of what all we did. We actually studied about the divisibility, about theorems of divisibility. Then we also studied about the standard forms and how those standard forms are actually important to us. And we actually saw the number of zeros in an expression, then also finding the number of zeros in factorial format. Then what the co-primes and relatively prime numbers are, we got to learn that. Then about the divisibility rules, then about remainder theorem and about the base system. I hope you people understood whatever I taught you, and I hope you people will look forward to next lectures as well. Thank you very much. Have a good day.